So the topic we're going to cover today, which might seem a little out of place being in a probability unit, is how to understand or to understand how to represent sets of data. And there is some tie-in because, as we talked about, we can represent probability or our outcomes in set notation. So a set is a collection of objects or elements. If you see this symbol, which is a Greek epsilon, that is the element symbol that is used. Okay, it looks a little like an E, but it's rounded as opposed to straight uh, lines. Okay, so roster form is a notation for listing all the elements using braces and commas. So we've done this before. So if we wanted the set of prime numbers less than 10, roster form would be to list out 2, 3, 5, and 7. Okay? That's helpful if there's not many elements in our set. Set builder notation is, and we've seen this one before when we were doing our domain and range, is notation using braces, and it gives a rule. And that's obviously helpful when we have a lot of items in our set. And then finally, the new one is what's called interval notation, which is two numbers enclosed by parentheses or brackets. Okay, those are the brackets, those are the parentheses. Now, the parentheses are like our open circle, and the brackets are like our closed circle when we were doing inequalities. Okay, so for example, 2 bracket 7 would be x is greater than or equal to 2, less than or equal to 7. Here it would be greater than, less than or equal to. Here it would be no equal to. And if you might remember, the 8 turned on its side is a infinity symbol. So that would be just x is greater than 2 because it goes on, greater than or equal to 2 because it goes on forever. Okay? So just to give you some examples of each, if I have the roster form of the numbers 2, 3, 4, 5, 6, 7, then what I would do is I would say x is the element of natural numbers, n, and it is between the numbers 2 and 7 inclusive. And in interval notation, we would do like above, where we would put brackets around both. If I said x is less than 6, then in roster form, okay, that's how I would list it out. Now, I probably would be a little clear here to make it that it's all integers less than 6. That's okay. And then in interval notation, it's negative infinity, because I'm going to the left, comma, 6. And they both have parentheses, because infinity can never have the bracket around it, because you can't equal infinity. And then if I'm from negative 3 inclusive to infinity, that means it's negative 3, negative 2, negative 1, dot, dot, dot. Okay? And x is all numbers greater than or equal to negative 3. Now, some of this doesn't perfectly align because you're dealing with, you have decimals and fractions in between, but I don't want to overly analyze this. All right, so which interval notation represents the set of all numbers from 1 through 9 inclusive? Inclusive means it includes those numbers, so it's number 4. The set 1, 2, 3, 4 is equivalent to which of these? Well, it would be this one here. 1, it's telling me it's a whole number, so they all kind of cancel out. But the key is 4 is included, so I need the equal to sign under the 4. And this one is greater than 1, so that doesn't work. This one is greater than 0, which does work. All right? Now, we also have a concept which you should be familiar with of what's called union or intersection of sets. The union of two sets, and you'll see it's the symbol with like a U. It's not exactly a U, but it's like a U, means putting two sets together. So it can be in one set or the other. Intersection is where they overlap. So that is separated by the word and that's the upside down U. It's got to be in both sets. Okay? If they have nothing in common, they are called disjoint sets, or we also sometimes will see the word null set, words null set, and their intersection is represented by the empty set with a circle with a slash through it, or sometimes you may also see the braces that are empty. Okay? Either one is fine. All right, so let's go to some examples. I have two sets, A and B, and I want to find the union and the intersection. So the union would be 1, 2, 3, 4, 5, 6, and 8. Okay? And the intersection is just 2 and 6. If you have elements in common in each set, and it's the union, you do not write them an element more than once. All right, this is an old Regents question. I want it right as an inequality, the intersection. So where do all of these overlap? Well, what you want to do is go to where's the lowest where they all are at, which is 0. What's the highest that they all are at, which is 40. So the way I would write this is T is greater than or equal to 0, because they have the filled in circle, and less than or equal to 40. All right? Now, let's go through a couple more set definitions. A subset. Set A, or any set, is a subset of another set if every element in one set is an element in the other. So, for example, is set A, which has 2, 4, 5, a subset of set B, which has 1, 0, 1, 2, 3, 4, 5? And the answer is yes, because every element in set A is in set B. Okay? Now, the universal set means every element that is in some particular set. The set of all students in a school, the set of all players on a particular team, or something like that. And what you normally do is you would represent it similar to a Venn diagram. All right, this is the universal set. A is a subset. Anything not in A is what's called the complement, or A prime. And the complement of a set is a set of all elements that are not in a particular set. All right? Okay, so let's go through an example. I have the set of integers greater than -2 and less than 6. So the first set I have, all right, is -1, 0, 1, 2, 3, 4, 5. Let's call that set A. Okay? Then a subset of this set is the positive factors of 5. So I'm going to call that set B. So my positive factors of 5 are 1 and 5. Okay, it said positive factors, and it can only be from this from set A. What is the complement of this subset? So in other words, this is the universal set. This is my set B, and I want the complement of B. In other words, what is in A but not in B? And the answer there is those numbers there. Okay? So again, what we covered today is various ways to represent set of data.